Welcome to Summarize Science. Today we are looking at a major problem in the world of tech. How do we regulate AI that even creators don't fully understand? Artificial intelligence now decides who gets a loan, who is investigated for crimes, and when a car should brake. Governments have responded with massive frameworks like the EU AI Act, but there is a critical vacuum beneath these rules. Currently, no one specifies what acceptable risk actually means in quantitative terms. This gap is dangerous because AI behavior can change drastically based on tiny, random perturbations. The researchers argue that relying on simple benchmarks can lead to falsely certifying unsafe systems. They found that leading models can shift from refusing to complying with harmful requests due to minor formatting changes. To solve this, they looked at the aviation industry, which has an incredible record of safety. In aviation, safety isn't a vague feeling, it is a measurable failure probability, often as low as 1 in a billion hours. Traditional software is deterministic, but neural networks are statistical engines that require a different kind of scrutiny. The paper proposes a two-stage framework to bring this exactness to AI. The framework uses tools called ROMA and GROMA to test the AI like a black box. Instead of reading secret code, these tools measure how the system reacts to random noise and input changes. This approach is vital because most modern AI systems are too complex for traditional line-by-line audits. They use advanced math to ensure that the results have a high level of statistical confidence. In the first stage, a government authority fixes a maximum failure rate and defines the environment the AI will work in. This is a normative act, meaning it is a decision about what society is willing to tolerate as residual risk. The researchers note that setting these limits is similar to setting a speed limit on a highway. The system is only certified if the statistical upper bound on failures does not exceed this limit. In the second stage, the developer uses statistical tools to verify if the AI actually meets that threshold. This creates an auditable certificate that is much harder to bypass than current self-certification processes. It also allows for recertification if the model or its environment changes over time. This shift moves accountability upstream to the developers rather than the end users. To prove it works, the researchers applied their method to a self-driving car's emergency braking system. They broke down the car's attack surface into specific failure modes like sensor glare and lens scratches. By adopting the aerospace baseline, they looked for a failure rate of less than 1 in a billion hours. This transforms AI regulation from a checklist of procedures into a rigorous engineering practice. The car's vision system was then checked against a safety budget to see if it was reliable enough for the road. If the system fails the test, the certificate is denied, forcing the developer to retrain or fix the model. This ensures that the black box of AI does not remain an unmeasurable mystery. However, they acknowledge that this depends heavily on the accuracy of the statistical distributions used. So, what does this mean for our future? We can start treating AI safety with the same mathematical rigor we use for pharmaceuticals and airplanes. The researchers emphasize that while their tools are powerful, they require lawmakers to make the first move. Society must decide on the numbers first before the math can do its job. This research provides the measuring instrument that has been missing from the legal architecture of the world. It is a massive step toward making AI systems that are not just smart, but demonstrably trustworthy. The call for interdisciplinary collaboration between computer science and law is now louder than ever. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of data and technology.